Hello, and welcome to the Gigaspace's live demo of Smart Digital Integration Hub, or DIH. In this demo, we'll show how to decouple digital services from systems of record and isolate them from each other, allowing for improved performance and security, as well as lower complexity of the enterprise IT architecture. Smart DIH is composed of 3 layers. At the bottom, we see the integration layer. The Smart DIH reads data from databases and other sources through our pluggable connector framework, which utilizes Kafka as its interface. This data is imported into the DIH hosting layer, which is based on an in-memory data grid, or IMDG, making the data highly available to the organization's business apps. What this means is that even if a particular database is down or overloaded, Smart DIH keeps this data available for clients and business apps, maintaining service and business continuity. You might ask, how is data transferred from the databases into the Kafka interface in the first place? The answer lies in the CDC, or Change Data Capture components, which we see here. In today's demo, you'll see 2 of these CDCs in action. The first is IBM's IIDR, which is bundled with Smart DIH as an OEM, while the second is Debezium Connect, a commonly used open-source CDC. These CDC components not only run the initial data load to Kafka, but also reflect any ongoing change in the source data in real time, so that any change in the database is instantly reflected in Kafka and ultimately in the Smart DIH. The elements highlighted here are the pluggable connector framework that enables utilizing any connector, such as CDC, batch, homegrown, or off-the-shelf, as long as it can write into Kafka. This component identifies the structure of the data objects and streams data and schema objects into the DIH. DIH can also learn how data schemas change over time, known as schema evolution. As the schema changes, the learner component enables DIH to identify this change and modify the specific object structures or tables in the DIH space that are relevant to this schema change. The data from DIH is made accessible to front-end applications through a low-code service generator, which creates data access services and REST APIs in a super simple way. Access to this data is also made possible by the Data Gateway component, which uses SQL to make the data available to various operational and reporting tools. As part of this demo, we will create a microservice in Smart DIH. This will be done by combining data in different formats, originally stored in 2 different databases, into a single result, which is then sent back to the microservice client. At the starting point of our demo, we have MongoDB containing a list of customers, and MySQL holding data on the accounts of these customers. This microservice is created completely independently from the origin databases. Even if any of the data services is down or taxed by a heavy batch load, Smart DIH can still serve applications with fresh data in high concurrency and low latency. Time to see how this is all done. This is SpaceDeck, the Smart DIH management and control system. We can see the 2 spaces that are currently configured in the system. If we go into the demo space, we see that the data is divided into 4 partitions. Each partition is running on 2 data nodes, backing up each other to ensure service continuity. Under space types, we see the 2 tables that we previously discussed. You can think of a type as the IMDG representation of what would have been referred to as a table in a database. These 2 types originated from the integration of MongoDB and MySQL tables using our data integration module, with Debezium serving as the connector. Under data pipelines, we can see the 2 active pipelines that enable those integrations. If we zoom into the MySQL pipeline, we can see the initial data load. The Configuration tab shows the originating data source, in this case MySQL, the topic we want to track, and the destination space, including the specific tables in the DIH that we wish to update. If we toggle out of the DIH system and into Kafka Connect, we can see the same pipeline alongside the parameters of the MySQL database that the data originated from, such as hostname, password, and the topic we want to publish data to. This is the same topic we selected in the DIH to track CDC events captured on the MySQL accounts table. We can view the data ingested through this pipeline by clicking the Data Query tab. In the demo space, we can type any SQL query, as we can see here. All the data shown here is read from the Smart DIH replica without hitting the systems of record. We can run a similar query, this time on the accounts data, showing that most of them are monthly accounts, while others are weekly accounts. As with customer data, the accounts data is also fetched from the Smart DIH, where it is stored using advanced in-memory technology, making this data both highly available and persistent. Now, let's run a join function to combine objects in these two tables. Since all the data is already stored in the DIH, as we've just seen, we don't need to access any of the originating databases and can simply run the join directly on the DIH. To do this join, I'm pasting a simple SQL query that I prepared in advance. You can see that this query is looking for a match between the accounts and the customer's datasets in a specific account, in this case, account ID 192. Once we run the query, we get an instant result showing the combined details of both the customer data, such as this person's name and address, as well as the account data, in this case showing that this particular customer has a monthly account. As we've mentioned at the beginning of this video, Smart DIH reflects any changes made in the databases it's connected to in near real time. To see how this works, let's go back to account ID 192, but this time to its origin in the MySQL database. I'm using dbeaver to go into the MySQL database that hosts the data of this demo, open the accounts table, and identify account 192. Now, I'm going to modify the key parameter of this account, changing it from a monthly to a weekly account. The change we've just made triggered an event that is captured by the CDC and sent to the DIH. If we go back to the DIH and run the same query again, we should see that account 192 now appears as a weekly account. We can double-check this to ensure that this change was indeed completed by running a general account ID query and running it against account 192. And here it is. The account now appears as weekly. Now, let's create a REST microservice for pulling data from account 192. All that's required is to simply hit the deploy key and name this new service. That's it. We can see this microservice under the Services tab. Clicking on it runs the REST service that we've just created. This will result in the account data in a JSON format, showing the updated weekly data. If we switch back to MySQL and switch the account type back to monthly, the REST microservice is instantly updated. The Smart DIH event-driven replica ensures that the data served to the applications is up to date. Since DIH is always running on fresh data, you can be certain that it's always in sync with the origin database. So just to explain what we've just seen, we've imported datasets from two separate systems of record onto the DIH and then combined the data and queried it within that single space. If we had to get the same result without a DIH, we would have needed to query the data on each of the databases separately, which would be far less efficient and prone to lower data availability. Up until now, we've been working with data that was already loaded into Smart DIH. Next, we'll show how to create a new pipeline, showing how quick and easy it is to connect a new database into the DIH. Let's say I keep some of my business data on an Oracle database, and now I want to add this data to the Smart DIH. I set up this new connection, select Oracle as the data source, and type in the connection URL that contains the parameters such as hostname, port, and PDB of the Oracle database. We then choose the database schema that we'd like the DIH to connect to, which for the purpose of our demo is called Retail. Once we hit Save, the new database appears on the top of our Data Sources page. Once this data source is defined on the DIH, we can go ahead and create a data pipeline for the Oracle database. We'll name it Demo, and in the connection type, we select IIDR, since this is preset CDC tool for streaming Oracle data into the Smart DIH. Once we set up this pipeline, we select the data tables that will be included in this new pipeline. For the sake of this demo, I'm choosing two tables, Orders and Products. Once we hit Save, the pipeline is created and already appears on the Data Pipelines page. Now that this Oracle data has been loaded to the Smart DIH space, I can run queries on the Product and Orders datasets. So far, we've seen how batch data is replicated into the DIH and is available for querying and other functions. But what about streaming data that is constantly changing? Let's see how we can run Kafka streams into the DIH. Back to the pipeline page, we select the pipeline that's configured for our Kafka stream source and hit Start. This data now starts streaming into the DIH, as shown here in the number of transactions that keeps growing. On top of these transactions, we run an event-triggered aggregation code, as we see on the top row in this table. Anytime an event is triggered, it triggers the aggregation following the setup we've configured. This is a use case that could be relevant for a variety of business use cases, such as risk scoring or fraud detection. Let's take a closer look at these transactions. We can see that each transaction has a specific dollar value and is associated with a unique account ID. However, since any single account can be linked to multiple transactions, we can run an aggregation query and quickly see the total sum of all transactions made under each unique account ID, as well as the number of transactions made to each account. We can quickly create a microservice around this aggregation query, as we can see here. We first run this new service on a specific account ID, and as soon as it renders the correct result, we hit Deploy and create this new microservice, naming it Get Transaction Aggregation. And here it is. Click on it, and the JSON message is right there. Over the last minute or so that the system has been running, it already loaded 300,000 transactions to DIH, creating over 2,500 aggregations. These aggregations are created in real time as data is ingested in the IMDG. That's it for now. So to recap, we chose a data source that we wanted to connect to the Smart DIH. We then created a data pipeline. the data started flowing in, stored in a unified and consolidated format that's easily accessible to the enterprise business applications. All this data is now available for retrieval using standard SQL statements as well as REST data access microservices that we created in a single click without writing a single line of code. Regardless of how your organization decides to use this solution, one thing is clear: Gigaspaces provides a simpler, faster, and ultimately a more standardized way to create new, high-performance digital services and reuse them across your organization. Thanks for watching.